In this video, I will show you how to identify relative maximum or relative minimum of a function using the second derivative test. So what is second derivative test? Well, for any function f that has both first and second derivatives, f prime and f double prime, on an any open interval ab containing c, and that first derivative at c equals 0, then f has a relative minimum at x equals c if f double prime evaluated at c is greater than 0. F has a relative maximum at x equals c if second derivative evaluated at c is less than 0. If f double prime evaluated at c equals to 0, then test fails, and in such cases use the first derivative test. So here is an example. So we're going to find the relative extrema of the function using the second derivative test. So f start with f of x. So f of x equals to x to the 4 minus 4x cubed plus 2. So let's differentiate. So to find f prime x, so this becomes 4 times 3x cubed, and then 4 times 3, 12 becomes x squared, and the derivative 2 is 0. Now differentiate again to find the second derivative. So the f prime x becomes second f double prime, and now 4 times 3, 12, and becomes x squared. 12 times 2 is 24, and it's x. Now we find the critical values. To find that, we're going to set the first derivative to 0. So we have 4x cubed minus 12x squared equals 0. So you can see we can factor 4x squared, and it gives you x minus 3 equals 0. Now we set 4x squared equals 0. So you can see you can divide by 4 and take the square root, so you can get x equals 0. So next is x minus 3 equals 0, and you can take the 3 to the right and becomes x equals 3. So we have a critical numbers 0 and 3, and now we're going to find out at which critical number the function has a relative minimum and at which number it has a relative maximum. So we're going to test the critical numbers on the second derivative. So let's test x equals 0 on the second derivative, 12x squared minus 24x. So we substitute 0 simply, and so this is like a c. This is actually c value, critical number. So we substitute c here and substitute x equals 0 here and 0 here, 0 here. So we have a f double prime 0 equals to 12 times 0 squared minus 24 times 0. Well, this becomes 0, this becomes 0, so we have a 0. So it looks like this test fails at x equals 0. So to check if the function has a relative minimum or relative maximum at x equals 0, so we're going to use the first derivative test. So we pick a number to the left of 0, so let's say x equal to minus 1. Substitute this number in the first derivative. And first derivative is f prime x 4x cubed minus 12x squared. So this becomes first derivative f prime evaluated at minus 1. 4 times negative 1 cube minus 12 times negative 1 square. Well, cube of minus 1 is minus 1, multiplied with 4 gives you negative 4, and the square of negative 1 is 1 times 12 gives you 12. So you have a negative 4, subtract 12, so you get negative 16 less than 0. So we can say that function decreases to the left of 0. Now we're going to test function behavior at x equals 1, number to the right of 0. Okay, so now we substitute x equal to 1 in the first derivative, f prime x equal to 4x cubed minus 12x squared. So this becomes f prime evaluated 1 equal to 4 times 1 cubed minus 12 times 1 squared. So this becomes 4 and this becomes 12. 4 minus 12 is minus 8, less than 0. So function decreases to the right of 0. Since f of x decreases both to the left and to the right of 0, we can conclude that there is no relative extrema at x equals 0. Now we test x equals 3 on the second derivative. This is your second critical number. So second derivative f double prime is 12x squared minus 24x. Now we substitute x equals 3. So it becomes f double prime evaluated at 3 equals to 12 times 3 squared minus 24 times 3. Well, 3 squared is 9. 9 times 12 is 108. 24 times 3 is 72. 108 minus 72 is 36 greater than 0. So now, by the second derivative test, we can conclude that f of x equal to x4 minus 4x cubed plus 2 has 3 comma f of 3 equal to 3 comma 3 to the 4 times 3 cubed plus 2 is equal to 3 comma 81 minus 108 plus 2 equal to 3 comma minus 25 is relative minimum. So here is an example 2. A manufacturer has determined that the total cost of operating a factory is C of x equals to 0.25x squared plus 10x plus 10,000, where x is the number of units produced. So find the level of production that will minimize the average cost per unit. So we start with this equation, C of x equals to 0.25x squared plus 10x plus 10,000. So we divide by x to find the unit cost, a unit average cost. So C prime x is equal to C of x. So we divide whole thing by x. Now we divide individually. So we have 0.25x squared over x plus 10x over x plus 10,000 of x. Simplify. So we have an average unit cost 0.25x plus 10 plus 10,000 times, you move the x to the top, x to the minus 1. So now we differentiate with respect to x to find the critical values. So the derivative of 0.25x is 0.25, the derivative of 10 is 0, the derivative of x to the minus 1 is 10,000 times minus 1 times x to the minus 3, subtract 1. Now we differentiate again, so we got a second derivative. So this becomes 0, and now we have just 10,000 times minus 1 times, bring down the power minus 2, and subtract 1, x to the minus 3. And now we can simplify, and this becomes 20,000 over x cubed. So let's find the critical numbers by setting the first derivative to 0. So the first derivative, we have a 0.25 plus 0 plus 10,000 times negative 1 x to the minus 2. So we rewrite. So x to the minus 2 will become 10,000 over x squared. So now we set this to 0, which means we set this to 0. So we have 0.25 minus 10,000 over x squared equal to 0. Now to solve for x, we can multiply. One of these is multiply x squared. So you multiply here, multiply on both sides. So this becomes 0.25x squared minus x squared times 10,000 over x squared equal to x squared times 0. Simplify, so we have a 0.25x squared minus 10,000 equal to 0. Now let's move the 10,000 to the right. So we have 0.25x squared equal to 10,000. Now divide by 0.25. And now we have x squared equals to 10,000 divided by 0.25. So using calculator we get 40,000. Now we take the square root. So x squared becomes x, and we have plus minus the square root of 40,000, which is plus minus 200. Now x, these are units, so units cannot be negative, so the answer is x is equal to 200, so we ignore minus 200. Now we get test the x equal to 200 on the second derivative, so we substitute, so we become 20,000 over 200 to the power 3, which comes at 0.0025, and now it's greater than 0. So by the second derivative test, we'll say x equal to 200 units will yield the average minimum cost per unit.